What is the resistance of a 20-meter long piece of 12-gauge copper wire having a 2.053 mm diameter? So, assuming the resistivity of the copper is 1.72 times 10 to the negative 8 ohm meter. Of course, this is at 20 degrees Celsius. Now, to solve this resistance, okay, the formula is R equals to the resistivity times the length divided by the area. So we need to know the length of the wire. So the length of the wire is 20 meters long. So given your length is 20 meters long. And then what is the resistivity? Resistivity is 1.72 times 10 to the negative 8 ohm meter. That's the unit. And then that what else? The given is diameter, which is 2.053 mm. Okay? So find the resistance. So we need to know what is the area here of that copper wire. Of course, the given here is in terms of 2.053 mm. So diameter. So this is the, let's say this is the wire, and diameter is given here. This is the diameter. Your diameter here is 2.053 mm. So what is the area of this circle? What is the area? So the area, the formula of area of a circle is pi r squared or pi d squared divided by 4. So we can use this formula. Now since diameter is given here, so we need to use this formula. Okay, so since this is mm, we can convert this to meter, but we will solve first the area in terms of mm. So your pi is actually 3.1416. 3.14, let's say 3.14 times the diameter is 2.053 mm squared divided by 4. So your area is actually 2.053 times 2.053 is equal to 4.2 times 3.14 equals, then divided by 4 equals 3.31. So this is 3.3086 mm squared. So that is the area now. Okay, so since our unit here is in terms of meter, so we can convert first mm to meter. Okay, so we need to multiply this, convert this area. So 3.3086 mm squared times, okay, in 1 mm, in 1 meter is 1000 mm. So this is 1 meter. Okay, and then this is 1000 mm. Okay, so this is squared, so we need to square it. So this is 1000 mm. So we need to square this one. This is equivalent to 1 meter. Okay, so let us divide this by 1000. Okay, so this one, divide this by 1000, and still divide this by 1000. So this is equivalent to 0.000. There are 5 zeros here, so this is actually 1, 2, 3, 4, 5, 33086 meter squared. or we'll make this in exponential form. This is 1, 2, 3, 4, 5, 6, 3.3086 times 10 to the negative 6 meter squared. So this is the area now in terms of meter. Okay, so let us substitute now this area to this formula here. Okay, now again, resistance, the resistivity is 1.72 times 10 to the negative 8, this is ohm meter, times, multiply this to your length, which is 20 meters, divide it by the area, which is 3.3086 times 10 to the negative 6 meter squared. So you have meter squared here, you have meter here, you have meter here. So meter, that is meter squared. You can cancel the meter here, unit. Okay, so cancel this out. What is left here is ohm. So that is the unit actually of the resistance. So we have to again divide these two, then multiply it to 20, or multiply this 2, then divide it to this. Okay, now 1.72, so I don't have exponent here, so I will just transform this into decimal point. Okay, so this is equivalent to 7 zeros. Okay, point 1, 2, 3, 4, 5, 6, 7, then 1 point 1, 2, 3, 4, 5, 6, 7, 1, 7, 2. We'll divide this by this one. So actually this is the decimal here, so we can just use this decimal, 5 zeros. 1, 2, 3, 4, 5, 3, 3, 0, 8, 6 equals 0.005, and then multiply this by 20, this one. So we have to multiply this by 20, equals is 0.104. Okay, so the resistance here, 0.104 ohm. So the resistance of this copper wire, size 12, with the length of 20 meters, having a diameter of 2.053 mm, is 0.104 ohm. So this is how we compute using this formula. Resistance equals to the resistivity times the length divided by the area. Okay, so I hope it's clear. Thank you.